Welcome to my YouTube channel, Mechanical Engineering Management, and this is the Machine Design Lecture Series. Today we are going to discuss about this chapter, Design Against Fluctuating Load, and our specific point for today is types of fatigue stresses. So let's see, first of all, the question that can be asked in your examination. Explain different types of fatigue stresses. And that fatigue stresses is specifically with stress time curves. Here you can see these are the different type of the stresses with stress versus time diagram. Fatigue failure occurs in materials subjected to the fluctuating stresses with respect to time, or you can say over the time, leading to the crack initiation and then propagation, even when the maximum stress is below the yield strength. The nature of these stresses is categorized based on the stress time history. So let's see first of all the different type of the fatigue stresses with their characteristics. First, completely reverse stress. Sometimes it is called as zero mean stress. Second one, repeated stress, known as non-zero mean stress also. Third one, fluctuating stress, having mixed mean stress. And fourth one, random stress. Now let's see one by one, briefly, all these four different type of stresses. So let's see first one, completely reverse stress. It is known as zero mean stress also. And this is the diagram for the fully reverse stress, or you can say completely reverse stress. In this diagram, you can see the stress value will vary from positive to negative, again from positive to negative. So first of all, try to understand the meaning of this fully reverse stress. The stress alternates symmetrically, here you can see in this figure, about a zero mean stress. Alternatively, that means first it will be positive and then negative, again it will be positive and negative, but it is symmetrical figure about a zero mean stress. The maximum and minimum stresses are equal in magnitude but opposite in sign. Here you can see this is the positive sign and here this is the negative sign. So this is the minimum value and this is the maximum value. Now stress ratio, generally you know that stress ratio is always minimum stress divided by the maximum stress. So in this diagram, if you can understand, this is the plus 5 value. Obviously you can understand this is the minus 5 value, and this is the minimum value minus 5 and this is the maximum value plus 5. So sigma minimum by sigma maximum, that means minus 5 divided by plus 5. So that will be minus 1. So stress ratio will be minus 1 in case of fully reverse or completely reverse stress. Now the mean stress, in this case the mean stress is always 0. Stress amplitude, here you can see stress amplitude, that means the maximum value from the mean stress line. So here you can see this is the mean stress line and the maximum value here you can see. So this magnitude is known as maximum magnitude and that is known as amplitude. So here you can say the sigma A is exactly equal to sigma max. Now the applications, rotating shaft, alternating bending loads. Now the stress time curve, here this is the stress time curve. The shape will be sinusoidal waveform centered at zero value. In this case, sigma maximum is exactly equal to the sigma minimum. That means the magnitude is same, but it will be in opposite direction. That's why sigma max is equal to minus sigma min. This is actually most severe for the fatigue due to the complete reverse. Second one, repeated stress, is also known as non-zero mean stress. So here in this diagram you can understand this is the mean stress value for this type of the stress, and this mean stress is not exactly on this zero stress line. That's why it is called as non-zero mean stress. And this type of the stress is known as repeated stress because of the nature is repeated. So the stress fluctuates between a maximum value and a minimum value, but both are on the same sign. Here you can see this is the maximum value and this is the minimum value. Both are on the one side of this zero mean line. Here both are the positive value. It can be negative also, or you can say it will be the compressive also. So here you can see this is the maximum value and this is the minimum value. Both are below this zero mean line. That means both are the compressive. Here also you can see both stresses are on one side of this zero stress line. The mean stress is not zero in this case. Here mean stress is 5. Here mean stress is -5. Stress never cross this zero line. Here you can see never cross this line. Again it will be repeated like this, but it will never cross this zero line. Here also you can see no reversal of loading like this. In the previous case we have seen there will be the reversal case, but in case of the repeated stress there will be no reversal. That means there is no positive and negative value. It is always either above zero line or below zero line. Stress ratio is always greater than zero, both value having positive value. So obviously your stress ratio will be greater than zero. If you consider this case, then both will be the negative value. So again the stress ratio will be the positive value, and so that R will be always greater than zero in case of repeated stress. Mean stress is never equal to zero. In this case you can see stress amplitude. This is actually the stress amplitude sigma A, and that is exactly equal to sigma max minus sigma minimum. That means this value divided by 2, then you will get sigma A. So sigma A is sigma max minus sigma minimum divided by 2. Applications: springs, bolted joints, automotive components, etc. Stress time curve. Here you can see this is not symmetrical about the zero line. That's why it is known as asymmetrical waveform about the time axis. This is less damaging compared to the fully reversed stress. That means previous one. Now the third category, fluctuating stress. Sometimes it is known as mixed mean stress. Here you can see the stress varies arbitrarily between tensile and compressive, but not equal value. Here you can see this is the tensile stress value from here to here, and this is the compressive value from here to here. So the magnitude is not equal and with a non-zero mean stress. Always in case of fluctuating stress, the mean stress line will not co-line with this zero line. Means mean stress having always sum of the magnitude. Stress ratio is greater than zero if sigma minimum and sigma maximum are tensile. R, that means stress ratio is less than zero if sigma minimum is compressive. Here you can see, and sigma maximum is tensile. So in this case the stress ratio is less than zero. Mean stress is never equal to zero. In this case you can see stress amplitude. Again previously we have discussed this is actually the stress amplitude, and the sigma A is exactly sigma maximum minus sigma minimum divided by 2. Applications: aircraft wings, automotive suspension components, etc. Stress time curve. Here you can see irregular waveform crossing this zero stress line. Here you can see. So it may cross this zero mean stress line. It has some mean value always. It fluctuates between two limits. maximum and minimum. The stress can be tensile or compressive, or partly tensile or partly compressive. If we are talking about the design consideration, then it will be moderate to high fatigue damage. Now the last one, random stress. Here you can see, this is the random stress. It is not like this completely reverse stress. The stress variation is irregular and unpredictable, means having no any fixed pattern like this. This is the common in real world applications. Stress ratio also varies randomly because of there is no any fixed pattern. Mean stress value again may change over the time. Applications, especially offshore structures, wind turbines, vehicles on rough roads, because of there is uncertainty and so that there is no any fixed pattern. Stress time curve, here you can see these are the stress time curve for the random stress. So random stress having noise like pattern, analyzed by using the statistical methods. Thanks my dear friends for watching this video. Press the like button and share and subscribe also.